All right, this is where the rubber hits the road. We're going to build a device, working prototype, in under 15 minutes. So what we want to do is, you've learned about all the details of OCF and IOtivity and the different tools we've got. What we're going to do now is allow you to forget most of those details and just run some simple commands to get you into the development cycle, get your board working, get it working with the hardware in under 15 minutes. So we've added all these tools. You are the first ones to see several of these tools. So you're a little bit guinea pigs, but we're very proud of them. And we've taken what was a difficult development system with a lot of details to a system where you can literally build a device in under 15 minutes and go through the test cycle. So you can concentrate on what you want to accomplish in your project and not have to worry about the details of all the OCF stuff. So I've got a few introductory slides here I'm going to skim over because you've already covered them. But basically, we're doing 3-pillar alignment, which means that every 6 months we're releasing an updated version of the specification, an updated version of the IOtivity open source code that is compliant with the specification, and an updated version of the test tool, which will verify that IOtivity or anything else complies with the specification. So you get that every 6 months. We've got a complete set of development tools. This starts out with OneIota, which is our open source tool. You can see it right now if you go to oneiota.org, spelled out. That is where all the resource models are stored. Now, resource models are central to everything. So they describe simple things like temperature, pressure, switches, things like that. And they're fundamental, tiny, small pieces of the functionality. You can make more complex resources by combining those into groups, and you make devices by adding resources. So the interoperability is defined at that layer, which means that you can define a refrigerator, which is a device, has a cooling chamber, maybe a freezing chamber. We define it minimally, so you can say you want to be a refrigerator, but then you can add your instant beer cooler or your special vegetable control panel or whatever, add those as new resources into that device and distinguish your device. But everybody who's a refrigerator has that minimum set of resources, and you will be able to control their refrigerator. They will be able to control your refrigerator as long as you have the authority to do that. So interoperability is the key component of OCF, the design system. So we define this on multiple layers. Well, we've got the tool chain that Wouters walked through in some detail. There's some very nice convenient scripts that will let you get everything set up, first of all, with that curl, and then after that, you run through generation of code and compiling and your editing and running loop. We've also got these great tools that automatically will generate your user interface or allow you to do detailed control of that. This is the hardware that we had for a demo that we did at CES and some kits we handed out there. So instead of the EnviroFat board, you'll have the automation fat board, which is more about control of sensors. So I wanted to say a little bit more about OneIota. If you go to oneiota.org, you'll see this. It's a way to open source and crowdsource all the resource models we have. It's a very simple sort of IDE for data models, and it has some process on the back end for control. So if you come up with a new widget, some sort of resource that you want to create, the first thing you should do is go in and see if it's already there. And then you can go through the process of defining that. There's tons of examples. I think we've got 100-something resources already defined. So you can scan those. Those are what you're going to use in your device description file that's going to drive all your code generation. So probably what you need is already there. If it's not, we're continually adding new resources to that, and you can add your own resource. To do that, you would create your resource, copying something somebody else did, and add your specific features, and then submit that. When it's submitted, it goes to OCF organization. We have a team that evaluates those data models and ensures that yours is unique and serves a useful purpose, and then you can get that submitted. Also, several organizations are participating with us, like EEBus and all join in that are submitting their own models. So besides just having models that describe basic functionality, OCF acts as sort of a central repository that's a superset of all those other models. So what happens is when we build bridges, those bridges automatically go through the resources defined in OneIOTA and allow you to interoperate with like Zigbee or Z-Wave or EEBus or any of these other operating systems that are participating with this. And we're getting lots of partners that are submitting their models. So it's really designed to break down those walls between devices and ecosystems. So we also use that to generate the code. We use that to generate some of our specifications. We actually generate the specifications from the real resources rather than vice versa. And the PIX file that we use for testing, the introspection file that generates the user interface, all that stuff, everything is centralized around OneIOTA as the basic resource. So let's build a device. In this demo, the environment is basically already installed on what you have. I have to do a little testing to see if everything is there in the right place, but if not, you can run that curl command to install everything in the right place. And then we're going to edit a device description file, then we'll generate the code, we'll run that, okay? So the slides here go through the whole process. A lot of that I've kind of done in advance to make the presentation run a little more smoothly. But this explains how to set up your Raspberry Pi and all the development tools. And then we're going to generate the device software and support files. So I'm going to switch to that and actually show you this. I put down some timing here. The first time you run through it, it's going to compile a bunch of libraries and stuff, and so it takes closer to 15 minutes. After you do that the first time, it's more like 3 minutes. It's really fast. So let me go here. Okay, so here's our Raspberry Pi. If you look on here, I installed a head version with a desktop, so I've got a bunch of extra stuff in here, but yours will just have, I think, this IoT directory. And that's where we're going to do everything. So I'm starting from the point where you've already basically run the curl command and gotten all your tools. So they're already ready. And I've compiled this once before, so it'll be a lot faster. So if we look in there, we've got a bunch of tools that we can use. The green ones here are the scripts that we've provided. And what we're going to do is, first of all, we're going to run the code generator that will build our actual device. So I'm going to do that. Oops, I have to actually finish my shortcut. There you go. Okay, so this is going through, it's building the source code for the device, it's building the introspection file for the device, and it's building the PIX file, and it's done. So hopefully you didn't blink, but that's ready to go. Now, one thing I'm going to do is I'm going to reset the onboarding file so nobody owns it. So there's a convenient script to do that called reset. And then I'm going to run the device. And there it is. We're done. But you probably want to know how to control it, so we're going to do that as well. Okay, so this is the onboarding tool generic client that Diego showed you. So we've got all the right stuff in the right places, and I want you to actually watch both of these screens here. So there's our client with OTGC, and here's our server right in the background. So it's just waiting to see what's going to happen here. So the first thing we're going to do on the client is try to discover the device. So it's scanning the devices, and it found one. It's called Energy. That's probably not what it'll really be called, but this is a minimum viable product. Okay. The plus sign over here means it's ready for onboarding. That means nobody owns it. I can take control of it. Okay. So I hit the plus sign, and now you can see some stuff's happening on the server with the security system. It's using the JustWorks onboarding method, provisioning the ACLs, and it's owned. We own it. Now if you go in with another onboarding client and try to own it, it's going to tell you somebody else has already got it. You're out of luck. And likewise, if we discovered devices and some of them were devices we didn't own, the device would still show up here, but it'd be in red, and we wouldn't be able to get to the user interface. But now that we've got it onboarded, it's ready to go, we're going to hit the little gear button there. And there's my user interface. I didn't do anything. It discovered that from the introspection file and build it. And so I'm going to go through here, and these are all the resources that are defined on my board there. So I'm going to click on the light, and you'll see in the server window, it's saying true. I can click again, false, true, false. I can turn on all of these, and I can come down here and turn on the relays. I can the inputs I can't select because those are just inputs, they're read-only, but it'll reflect the state. So if I put in a voltage on that input, it would show 1 or 0. Likewise, if I do it with the A to D converters, it'll tell me the voltage that's on that A to D converter. So you may be wondering, well, why isn't anything happening on this board? That's what you got to do, okay? So what we're going to do now is we're going to go through the development cycle again, but we're going to add in the code that interfaces with that particular board. And I've provided code so you don't have to write that. It's pretty tricky because I've only got Python libraries and calling them from C, and I had to learn how to do that, but it's working. So we're going to exit our onboarding tool here. Oops. And we're going to go back and do some code. So coming back here, and you'll see the development cycle stuff here. So I'm going to Control-C out of this. I'm going to run a different script just to show you how it works, called edit code. And that brings up our C code. And you can see that this will do everything that you've seen so far. This is automatically generated. I didn't write any of this directly. So with nothing going on, you'll be able to see it go through all those resources. It'll put up the value of the switches, et cetera, so you can see exactly what's going on. But I've written the code that does the interfaces, so I'm going to just copy that over here. So I'm going to get out of this, and I'm going to copy. I should have written a script for this, but I didn't. So you're going to have to bear with me as I type this out. Let's see. I got to remember where it is. Okay. Come on. There we go. So there's the C code, and I'm going to copy it to the directory that does the actual execution or the compiling stuff. So I can remember where that is. Okay. All right, so I've copied over the code that actually does things. Also, since these are Python libraries, I have to type in another little command here to make sure that those work. All right, so now we're going to use the build script. And we'll go through the compile chain. Since I've compiled the libraries and stuff already, it's going to skip through most of this stuff, and then it'll get down to compiling the server.cpp code that I just built. And it's not displaying that, but that's what it's doing right now. Takes about 30 seconds. So just while it's compiling, I'll explain. Oh, there, it's all done. Okay. All right, so now I'm going to, I'm not going to reset it to ready for onboarding state because I already own it, so I don't have to do that again. So I'm just going to run it. So there, that's running again. Let's bring up our user interface. Okay. And we're going to go through the discovery process again here just to make sure, show you that it's still discovered as a client or as a server that we own. Okay, so that's there. And now we go into this. Our interface is still there. And with any luck, there's our comms light, there's our power light, there's our warning light. I'm going to turn on the relays. If you listen closely, you can hear those. They just click a little bit. And that's it. We got a working hardware prototype while I was on stage. So, thank you.